Um, Hi, how's everyone doing?
Good. You haven't shared your screen.
Of course I haven't. Why would I remember to do things like that? So yeah, do we just want to get started? Let people show up as they will? Let me
Sure.
post a link to that in the chat. But, I think this is interesting to read, but I will not try to paraphrase it. Um, I had already read the first paragraph, so... Um... Oh. Is this script in Arabic?
Looks like it.
I don't know why that's being mentioned. Why that's there. Property of the digital scans goes to... Oh, okay, this is like the 90s, you know, Resident Evil, the original game being popular. I think this is just showing how popular it is. It's popular in non-American, Japanese, or English, uh, or European markets. Interesting.
Yeah, probably because of Arabic is because of the author familiar with it.
Oh, is that the author's origin? Oh yeah.
I don't know who that is, but yeah,
With the
his
name
name.
Muhammad, it's very likely. So, okay, I didn't know that about the author. Guess I had no clue what their background was. Um, okay, whole bunch of screenshots here of... Okay. Oh, it's all the Resident Evils, or some of them,
I
rather
think
than
it's
a
the
single
last
one.
three that have come out.
Yeah.
It's kind of interesting how they basically just, when they're improving their engine for their next one, they port all the last three to it as well.
Yeah.
I think probably almost all the in-house engine done in this way. It's really too expensive to throw away all your code and start again.
Yeah, I'm just more surprised that they updated the old games as well instead of just leaving them as is.
Um, it's interesting that they port it to the new engine, and it's like, instead of trying just to keep the old one up to date in terms of like bug fixes for when they want to re-release, they're like, well, it's the same game, we just got to redo it in the new engine, and you know, the workflows are similar, so Um, so yeah, this is an RE Engine deep dive. Noting that they had to rebuy the games because he had got them on console and not PC, and it's a lot harder to dissect games on consoles. Beast of a computer, and 4K resolution. Oh. So there's upscaling discussion. I think I can hear someone's bowl scraping. Whoa. Okay, so there's multiple resolutions being used for different passes. And they're kind of odd numbers. What is that, a quarter?
I can do the math really quick.
Yeah.
So that's 77% scale for the top one.
Okay, so 77%. I mean, that's close to 75%. Which is more like 50% probably, because it's it's a squared value.
Yeah, and then the other buffer, or the other size, is 38%. So I'm not sure why they chose those numbers or how they chose them.
Yeah, I'm gonna guess, like, if we got 38, 40 times 2160. That's 8 million. And if we do 2953 times 6061. I muted Fortune for the time being. Okay, 1661, and I guess divided by 8294.
Is PC games often being done in this way, like outputting fixed resolution, or it's just console game?
I thought it was common for a lot of games to have alternate, like, different resolutions for different things. Even if they're doing like a mostly full scale, whatever, because they just find that this pass doesn't need full resolution, so they'll use a half resolution. But these numbers don't make any sense for that, unless they're like...
I know, but just do they just use? I guess so, because most games usually have several options for resolution, but it's not something you can just adjust at.
It's like 1476 times 830 divided by... So like the second one, it's a 15% of the full 4K. So maybe just looking at these, like, in comparison to 4K is a bit misleading, because they're using the FSR, and these might be just determined to be the best resolution to get the best performance and quality. It's like a trade-off, a bit more resolution but a bit less performance. So this is these are the values they chose, which is just interesting. Okay. Just describing the process of capturing. Okay, so we got... I remember us discussing when we first saw this article that the the D3D12 usage is absolutely different than the Elden Ring's usage of it. And it actually used, or Resident Evil actually used D3D12 features to their full potential. Compute dispatches everywhere.
Yeah, well, with indirects, then you must do a compute prepass. Well, not really, but yeah, otherwise you don't need indirect.
Wait, that's... Oh, the God of War study is where this comes from. The meme. Okay, it's a different study of his from January. Okay. Okay. So... all the different compute passes in execution order. Jeez. Of course, this doesn't indicate which ones are dependent on previous ones. Skinning. Oh yeah, skinning. I guess computing GPU particles, computing lights, histogram adjustment. I wonder what that is. GPU calling, instancing, subsurface, screen space, subsurface scattering, I believe. Getting velocity, high Z, isn't that hierarchical Z buffer tracing? Wonder what they're tracing for. Compressed depth, normal, ambient occlusion. Okay, interesting. The GPU particles and the particle collision are separate. Possibly as now they have a depth buffer to work with. Screen space reflection, motion blur, deinterlacing? Depth of field, the FSR tech, and CAS. What was CAS? Do we... I guess... Well,
Contrast, adaptive sharpening. It's the second half of FSR.
oh, okay. Well, good to know.
Yeah.
A whole bunch of vertex descriptions, position, normal, tangent, and 2 text chords for most things. Yeah, I mean, yeah, for static objects, that makes sense. For skin meshes, it's the static object plus 2 indexes and 2 weights, which, would you consider that standard, or is that just my presumption?
It looks standard. I don't see any like vertex packing going on here.
Oh. For... So, humanoid skin meshes versus humanoid. Non-humanoid. Oh, I'm sorry. I just broke a plastic doodad I was holding in my hand. And I'm kind of annoyed, but I'll have to put it down for now. I fidget things with things, and what's the consequence of my fidgeting? I'm not going to share a picture of it. It's a stand for a fan. It's nothing interesting. Hair and eyelashes. Have you... basically, all these three are just different in the number of index and weights they use. Oh, and this one has 1 text chord versus 2. Also interesting that they only store normal and tangent and nothing else. Like there's like a bitangent or something.
You can deduce the bitangent from the normal and tangent.
Yeah, it's something I've heard before, so...
I guess you just do a cross product, right?
Yeah.
But I'm missing something. What are those numbers off to the right, actually?
Here?
Yeah. Like the all zeros and the 4.
That the amount of padding or something in between?
Yeah.
Yes.
Because this is a... Well... No, that's a 32-bit. You know, it might be that, no, maybe not. That's a very good question. What is it? Should we look at the previous, behind the frame thing and see if it says there? Because I have no clue what the 8s and 4s mean, other than possibly padding. But, like, they're all on the 4-byte boundary. So I'm not sure what it would be. Unless, like, normal and tangent are packed and the weight and index are packed together. So it's like the first 16 bits are index and the next 16 bits are the actual weight value.
The weights are. I mean, the index is unsigned int though. Types
Yeah,
are...
that's why I'm
Oh, no, yeah, I don't know.
I don't know. Volumes are just a position. Yeah, well,
Yeah.
that's all you need. Okay, I'm just gonna quickly look at this one and see if they have vertex layouts. Well, that's different.
That looks like the offset that you normally do, right?
Yeah, like this is
Oh.
You're
at 0.
describing the vertex.
So
layout.
that's an interleave attribute or vertex struct, and the other ones are like multiple arrays, I'm guessing.
That makes sense, because if you're looking at this, you can see 1, 2, 3. So over here, all of these, like, these are 2 separate buffers, but the normal and tangent are interleaved together. And then here, all of this is together, but this and this are separate, whereas these 2 are together. Okay. Yeah, okay, that makes a lot of sense.
That makes sense.
Thank you.
It wasn't very clear though.
No,
until you
no!
saw the very last one.
Yeah. Opie. Typo. So it seems that they're clearing out the state from the previous frame. Because it seems it's writing and clearing a buffer. But it's also doing a transition? I'm not quite that familiar with the DX12 naming of things.
I wonder why they do that instead of just issuing a command to clear the buffers.
It's also, it seems to be, this happens multiple times. This is just the first time it happens, and so there might be variations.
Oh, you can see at the end of that paragraph, so they have, looks like a big main buffer to store stuff, and then they copy it to per frame buffers, it looks like, at the start of the frame.
Oh, I see. That's the copy part of it.
Okay.
And I guess they want to write to it as well, so that's why they're doing the transition. from the structured buffer to that read write structured buffer.
I feel like GPU skinning only makes sense, but it's odd to think that people are still doing it on the CPU, except in compatibility contexts. But I don't actually have that big of a grasp of what everyone's doing, so I'll have to take their word for it. A lot of things.
Is this like where you're creating all the matrices for each like joint and everything?
You're calculating the blend weights because the
Oh, because you're interpolating, right? So
yeah, because you got
don't know
all
where
the
you are.
things.
Yeah. Okay.
So well, that's what I think it's doing. I'm not certain.
Yeah. Okay. I guess that would make sense to be done on the CPU side of just recently being moved to the compute chain.
Here's the linked article. Are there pictures? No, there's just compute dispatches. And so yeah, it's calculating the weights for the skin things on the GPU. Okay, GPU particles. Like how it's labeled which pipeline it is. Okay. Okay. So this is one of those things that can just kind of be kicked off, and then the time it's actually needed is later, which is, you know, right before post-processing.
Makes sense.
Ooh. That's a big hunk of data.
Yeah.
Position, size, scale, tangent. Color ratio. Birth offset. Velocity. Rect. Index. Timer. Front diffuse. Text speed. Yeah, these are like things you'd be set in a particle you all of these have defined value, defined meanings, and your particle sim will, you know, use them to determine what happens. You know, how long it's been alive, how many loops, UVs, blending, all sorts of stuff. I don't know what the difference between a constant and particles is.
Are those uniform across the entire system?
Possibly.
Maybe.
Then we have the emitter instances and then the emitter, which are basically keeping track of the particles that have come from that emitter, and then the information about the emitter. So are these... I wish you could open both at the same time. I want to compare them, but no. Extend particle vertex constant. Okay. Constant buffer, particle buffer, byte offset, particle length. Reserved, and the headers? Oh boy, this whole particle thing is complex. There's a vector field. Oh boyo. You have frequency stuff too.
A lot of floats.
Mm-hmm. Like, I bet all of these are different sliders for controlling the... I guess... would this be something... I'm imagining that you'd want to use this to, like, do wind simulation?
That would work for that. I think.
Yeah.
I know they're. I only really know vector fields from like generative art stuff. I guess it's probably the same thing if you're doing the on a billboard, but yeah, it's all like movement. So yeah, wind would probably be a good use case.
Yeah, it mentions forces and environment-related forces, so wind and stuff makes sense. Field attribute.
Probably use a vector field for like maybe like raindrops on a surface too. I don't know if that's anything to do with particle stuff.
I don't know. This is kind of mesmerizing to watch it change. It also, every block, you can tell every 4x4 block is... can I see... Can I pause it? No? Are there no controls? Dang it. Like, each of these 4 blocks has a different palette in it.
Yeah, that's interesting.
And it's like, it creates these kind of weird... I don't know. Maybe it's like, this is the 2D representation of a 3D volume? That seems a bit odd, though, since they're 4x4, and... I don't know.
I would say it's... Oh yeah, that's the vertical flow.
64 by 64 by 64? Is
I
this
think
just
it's
some, like, visualization of a 3D texture?
Yeah, I think it's just showing different layers of it.
Oh! What's confusing to me is that every, like, thing, every 4x4 chunk, tile or whatever, is constantly changing the color palette. It's just... I wonder if that's just because of the way it's done, the calculation.
I don't know.
Yeah. Okay, so we got clustered deferred rendering, meaning the light is clustered, and so light instances only affect certain areas.
Sounds like they're implying that the clustering is for gameplay reasons and not necessarily for performance.
Yeah, I would have thought it'd be performance first, and the fact that it's, you know, using rooms is a reason why clustered works really well for that.
And you wouldn't need clustered rendering to like call lights from different rooms either.
Yeah.
Well, I guess maybe you might. So that might be annoying to do if you didn't have light calling really.
Hey, you got the scene info. So you got the view projection, transpo view matte, transpose view inverse matte. So it's like all the things that you might need are pre-computed ahead of time. Projection, project inverse, view projection inverse, pre-view proj matte.
What are those? The projection element. What's that? Oh wait, or float. Wait, why is that
Oh,
array of float
the
colors instead of a matrix?
I bet you this is float. Wait, float 4 array? Is that like what?
Yeah, I mean,
I don't have any idea what that could be for.
I don't know HLSL, so I don't know. Like, I get float 3 is is like the GLSL Vec 3. And
yeah, it's
float
the same
4 Explorer
thing.
is a Mat 4, but
So it's like a 4-element vector and an array of those.
What's the
yeah.
size of it?
That's a good question.
At least in GeoSL it makes sense because you can only put a single one of those at the end of the struct, or I guess the buffer.
Yeah. Who knows?
Well, it should be known, like the size of it. Like,
Not using infinite field of, or infinite far plane. Nah, it's fine to have a far plane. I just find it interesting. Hey, variable rate shading velocity threshold. Reserved. Okay. Light spheres SRV, light culling list count. What are we looking at here? Oh, the CompuPass. Pass.
oh wait, so light sphere, I guess it's just the bounding sphere light.
I would think so. Is this like a... Oh, this is the same thing but animated, and this is like a left to right, top to bottom of a 3D texture. So you can see that these bars correspond to these ones, and then the fade out at the bottom is this thing.
So, does anyone know what? I've never done any like calling or anything. I guess like what would you be storing here?
The list of lights per cluster, I would think.
Yeah, that would make sense, I guess.
Yeah, but it'd be like tightly packed, I believe, and then there'd be another buffer that holds like an index that points to the beginning of the list of lights for that cluster. There's like a lot of indirection, but it totally works in the end, trust me.
It's a lot of floats and data here. I wonder what the light parameter versus light info differs. It's just a lot of parameters here. Histograms. So they have instead of taking the whole scene into account, they're metering the, well, I was about to say brightness, and they mainly consider areas in the middle of the screen, it looks like. Yeah, because
I guess it can be different per frame, I think it sounds like, the mask.
Yeah, but it's also like, these four are nearly identical, they're just, I think this one's a little, I can't tell the difference between the four. And then this one's just a white box. Oh, it's okay, so we have, like, these are different example scenes, and these are the masks they use with them. And for this one, so since it's a, cinematic or whatever close-up shot, they want the whole scene to be considered. But here, they really want the face to be considered, and the background can just go get screwed. Do. And they're not going to explain how it works because it's not what this thing's about, apparently. It's the histogram.
No weird.
They had a typo. Max, min, white range, dark range, bit rate, bright rate, not bit rate. Update. Okay. Do we want to spend time trying to look at these numbers? Because I don't.
Probably not.
I mean, it's these two, these are the same. It's 65k and 0. And then these differ somewhat, but the white range is... Well, there's differences. I forget which one applies to which, though. Oh, I guess for the 5 above. Oh, they're used later. So is there a test or something? No. So they're doing clustering and doing frustum tests. I can open multiple if I do it fast enough. Okay. Culling world. Count, offset, matrix. Bound min, clustered offset, bound max, shadow clustered offset. Huh. And then GPU volume, 3-axis, center, scale, output address. Oh yeah, I guess the right address. Or the... wait. What? Okay. I'll take your word for it. Can anyone summarize what that paragraph is saying?
I can figure it out myself. I guess that's really just doing just testing all the different objects, bounding boxes on the depth buffer, right? I think that's what it's saying. Just generate out of. I guess, yeah. Just render everything in depth buffer. That's the...
Okay, so apparently the author isn't quite sure either. And it... Okay. What the heck? These are all like tiny images, 128 by 64. And so like they're big chunky things rather than very fine-grained. So is it... Did it like predefine the occluders?
Yeah, it's all like simple environment, just like blocking out the scene.
Yeah. Rather than trying to be uber generic, it's like, well, we know where there's going to be things blocking other things, so we'll just, you know, put the occluders and, you know, the most basic and large bits of the scene we'll make into a, you know, an occlusion thing and render that, and then we'll occlusion test everything else against it.
But the weird part where they say there's no MIPS in it, but they still store it at different resolutions.
Yeah.
Stores different values in the different samples. I don't know what that means. Like different samples.
I don't know.
Maybe it just is it like they have 4 different like levels of the pyramid, but then they only store one sample, and that's going to be like whatever one's useful or something instead of generating like the whole pyramid.
Ooh.
I don't know.
Okay, I'm just gonna move on to instancing, because I feel like we'll have more idea of what's going on there. So... we have instance draw info, count, multi-count, data byte offset, indirect indices buffer byte offset, and reserved. Let's see, oh, an array of struct. It's like the instanced indirect info and then the multi-draw indirect. Multi-draw info. Count. So what's the difference between these two?
Sorry, what was the question?
What's the difference between these two structures? They look deceptively similar. They got a count, they got an offset, data offset, and then a byte offset. Well, this is indirect indices buffer byte offset, and this one's count byte offset.
Is it just like whether maybe you can't always do multi-draw or something? So there's like alternate structs to use? I don't know.
Yeah. We have a light parameter which has stuff. Okay, so they're executing draw commands that read from a buffer on the GPU, and that's what all this, with these structures are storing data about. Oh boy. It's a lot A lot of individual draws. I wonder if they're individually interactable objects. Hmm. Well, it seems like some of these are meshes of several objects rather than
I think
individual.
it said when multiple objects show up, that's the instance.
Oh,
But not
okay.
every here is instanced.
Okay.
As they say, like the character model is not instant.
Hmm. So we got 50,000, 60, 110, 130, 133, 163. Ooh. 163, 263, 260, 278, 288 plus 80. Oh, 300. So it's like 350,000 vertices for the main character.
Seems like a lot.
For a hero asset, that seems reasonable to me. I mean, there's lots of little things that they've added. I mean, just 2,500 vertices for the buttons alone. Okay. So
What's that modified one?
This is like the shoulder, arm, and wrist. I don't. You got your albedo. Got your normal. Oh, you got an alpha channel for the normal? Interesting. We got the depth, which is. You can see the hair has holes in it. Can you see
Yeah.
that? Yeah. The hair is fuzzy. Got the normal map, which I'm gonna go over to the hair. Yeah, the hair has normals on it too, and it isn't just the head underneath. It's interesting. VYX AO subsurface scattering? So hand, head.
They should explain a little bit below. Yeah, velocity, XY, ambient occlusion, and subsurface scattering.
Oh, in a in a 48-bit thing. Okay. Plus AO. Plus mask. Ah, mask. Okay.
Oh yeah, that's why it's only his skin.
So this is everything combined, but this one has more stuff in it. Oh, you can barely see that.
Oh, wow.
Can you? Yeah, here's the gun. I don't know if you can see the thumb or the hand. Yeah. Where is? Oh, that's much. I bet this is the y-axis, It says R, and this is G. I bet this is the y-axis because x-axis because it has a lot more motion going on. It's moving left to right. Oh, hello. Ambient occlusion, and I think this is the subsurface scattering mask.
Yeah, that sounds about right.
What's this one then? Oh, that's the swap chain. So this is the final thing, and of course, it's dim as all heck. But you have the blurring hands here because of the velocity. Yeah, okay. Yeah, they're all full of stuff. Oh. Oh! The modified G buffer is tracks between?
I don't really know what that means.
I don't follow. Huh. Hmm. I'm sorry, is that a typo? B-O-U-E instead of B-L-U-E?
Probably.
Probably.
Hmm.
Or maybe it's French.
Is that French for blue?
No.
Okay. You could have
It's
said
just
yes
a-
and I would have believed you.
It's just a French-looking combination of vowels.
Yeah. Yeah, the Japanese developer known for their French fanaticism.
Yeah.
It's just showing us some objects. Purple medicine bottles. It's just me, the kind of person who's like, yes, let's read the imaginary label. But it's probably like lorem ipsum, and they just scaled it down so it couldn't be legible. Wetness. So this is where the wetness comes into play. You got some water trails, you got some raindrops, you got some noise textures. What is this? Alpha? Hey. You got the raindrop, is this? This looks like it'd be a raindrop atlas.
Yeah, it looks like it. I wonder how they generate that.
That's a good question. What's weird is they have these big sections and they have the little patches of gunk. Yep, very epic beard. It's just a bunch of cards, I think. How did they do that? Are they like individual lines for the hair?
It looks like wireframe of a triangle mesh. Oh, but then I see...
Yeah, for the beard it looks like a
Yeah.
wireframe, but for the eyelashes and eyebrows it looks like individual hairs. That, or they're so small they look like individual hairs. Or individual wires.
Yeah, they're probably still hair cards, but just really thin.
Yeah, hair cards. Yeah, we get we get the gunk that you draw last. The decals. Some pretty neat decals. Got the graffiti, the street things. What is the properties? Is that like material property?
Maybe, because it said it was PBR ready, so maybe it's... Oh, color normal and property. That's saying that it's part of the PBR, so it's probably like roughness or something.
Yeah, I can't imagine they're doing a huge like specular thing on it, because it's like most of the things that they're wanting decaled wouldn't be shiny, or very shiny, I should say.
Yeah.
Step by step is always better, sure. What was the... Are those volumes? No, those are quads. Yeah, they're quads. Okay. Because, like, the Elden Ring had, like, volumes for its decals.
Well, you can see right here, there's
Oh.
volume. I still don't really understand that, because like I don't see why there's blood has to be volume rather than just a quad.
Imagine if the surface is not flat.
I don't know.
Like, imagine if it's, I don't know, on a pillar or something. I think the point of the volume is for that to
Wouldn't
work.
that still work with a deck though? Because it would just be, sorry, like with a quad, because you just put the quad in front of it and then.
Probably doesn't
I
take
guess
into...
you have to.
Yeah, it doesn't
like the
take into
normal.
account the surface. Of course, it's being
It's
drawn on the
stuff.
floor, so you have to wonder, I was like, well, the floor is flat, but maybe these are being drawn on unflat floors.
Yeah, we should really have a day where we
I'd love that.
go in depth about decals.
Yeah.
I think we had a similar discussion with the Elden Ring
Yeah.
decals, like wondering certain things.
2 draws for all the blood and footsteps. Much better than... Yeah, much better than Elden Ring is not a very high bar. Far cube map. Ah, we get the background sky and clouds and stuff. An IBL texture. Okay. This game takes place mostly indoors, therefore we don't really need to do a whole bunch of work making a background other than a cube map or, well, IBL texture. Yeah, it's a pretty nice background texture. Ooh, nice sky. Exposure, rotation, axis offset.
Why you need that?
What was that?
I wonder why you need the axis offset. Maybe like if you are your character, like your scene is higher up in the world or something, you wanted to.
What
I don't know.
is? What? Oh, that's the foreground. Okay. And this is the final render, and you can't see the sky more or less. Can we see it here? No, we can't. But it might be used to look up into the like texture lookup and whatever. I'm in the outdoor. No clue. Fill velocity. Is it linearizing the depth?
Looks like it.
Why is it... Can someone explain typeless here? Is it just raw data and they're like, it's typeless?
Yeah, I'm pretty sure it's just like means it's just it'll keep the raw bytes you put in there and not do anything to it.
Yeah, I mean, snorm, unorm, int, uint, float, they all... Whenever you load the texture data, you interpret it into a specific format to mean a different thing. So it's saying, yeah, here's 32 bits. Use it like 32 bits.
I guess also they may be. Does that imply that they might be packing it differently? Although I guess if they're showing it here, it's probably not packed weirdly.
Well, this is the D32S8, so it's also got the 8 bits for the... Not alpha, stencil. There's the word I was looking for. Sorry, I couldn't resist doing my best snake impression. Okay, so the screen space subsurface scattering needs a mask for which areas to apply. And so you get like we take the SSS mask out of the G buffer and use it for stuff. This is what the mask looks like. Is it a binary mask? So it's like, oh, this is JPEG compressed. Ugh. But it does look like there aren't partially screen space.
Binary.
When I say binary, I mean it's a discrete. It's not continuous. It's either a masked in or masked out.
Yeah.
But it could be, they have 8 bits. They have 255 values to work with. But like leaning in, trying to look at these like whiskers, they look very much like they're single pixel wide. They're not a blending thing or a smooth thing. So we got screen space reflection. We got to trace through the hierarchical Z buffer.
This wasn't used for the culling earlier, which is weird.
It will be used later, thanks. Resolution offset. Neat. You got your SSAO, you got your set areas only. Oh, HBAO plus. You got your your cacao. No AO. Do we want to, like... I can't open the... Let me middle mouse click open the dang image. So we got our HBAO, we got our SAO, and we got our cacao. I don't know how you're supposed to judge these visually. Like, there looks like there's artifacts here. For the...
Like his jacket looks way
Oh,
less
there's a
detailed
halo.
here.
Yeah, there's a the halo around the jacket's a bad sign. This one looks quite natural. So does this one. This one looks more sharp, whereas this one's a bit smoother. So the cacao is more like smooth gradient, but the HBAO has a much stronger contrast. Ugh, look at the blinds here. Just do not like that. Whereas the HBAO looks fine, but maybe it doesn't matter. It doesn't seem to have a ray traced AO. Oh, you know what? There might be. I don't know if there is or isn't. However, the author mentioned that he couldn't capture ray traced anything. So there may not aren't any captures where ray tracing was enabled, from my recollection. Oh, it actually explains the different steps. Linearized depth, not death. De-interleave depth. What? Oh. 16 slice cascades. What? Why are there 16 slices? What are they slicing? Oh. No, I don't follow. I don't actually know how HBAO works in detail, so you know, that's fun. Jitters them? Oh boy. There. Blur X and Y separately because we can, because they're separable. Okay. Do you want to try and spend time understanding HBAO, or do we want to keep moving on? We're already at 8:13, and it's
The reason for all those atlases, or the atlas, I believe, if my memory serves me correctly, it's an optimization for the algorithm. So each pixel samples along a line several times to get the AO for that direction, and you gotta do that in several different directions. So I think each element in the atlas is related to one particular direction.
I see. So it's like I look in the northwest direction in 3 pixels, and then I figure out what the depth is and store that in the jitter, because it'd be jittering in all directions. Okay.
I'm trying to find, there is a GitHub repository that explained it, or maybe it's some PDF I'm looking for right now.
That'd be another thing we could totally spend a week on, is HBAO plus specifically, but just different screen space ambient occlusion methods. Okay. Compressed. What? It compresses the depth normal. So the reason why this looks the worst is because it's the cheapest and simplest one they do, so the SSAO is not... No wonder it didn't look very good. Scale and blurring. Yeah. Oh. Oh yeah, HBAO. Local light sphere, okay. It's talking about AO. Screen space. Z buffer. Yeah, I guess we should... yeah. I don't think we should spend too much time on this, but it's good to have the paper handy. You do MIPS and downscaling of the depth for cacao. Downsample normals. Okay. Normal atlas. Is that kind of like jittered, but it's the normals that are jittered? Q3 base, what is that? Hey, ay. AO importance. I can see it's generating halo around the guy's head and around objects of distinct depth values. Post-process. Oh, so that's, well, edge-sensitive blur. So it tries to find the edges. Oh boy, oh. That's, found lots of edges. Edge, does multiple blurs, apparently. Okay. Does it, wait, does it just do the same thing twice? Edge-sensitive blur 1. Once per jitter slice in order to generate the edge-sensitive blur. So almost the exact same thing. Okay. So it is known. Upscale stuff? Okay, we got parameters, of which there's plenty of them for the cacao. Particle depth emitters, yeah, because depth-based particles need to be emitters, particle stuff redux, but now that it has the depth buffer, it can take that into account. So, do we know what type of indirect illumination they use? Did they use cube maps for everything? Oh, this
They mentioned the IBL with the skybox earlier.
Yeah. Oh. These are cube map renders around the scene. Can't tell what's in each of these other than stuff. Whoa! What is this? Oh, outprobe index cache. Okay. That's... Oh yeah, wait, don't need those. Well, maybe that one, but... Oh, this is the light culling volume stuff from way earlier. That's... interesting. Well, here's some... Well, those look trippy, but I believe they're just, like, buildings seen from the corners of them. Also looks like it's upside down. Anyhow.
Create those. Like, do you think they have like a ray tracer or something that they run offline?
That's, from my understanding, that's kind of what, well, that's kind of what you did for a lot of games, is you had like a had an offline light probe thingy that you'd run, and it'd bounce a bunch of rays around the scene and see where it's dark and bright, and then you bake that into a texture.
What if they just use like the Maya renderer or something?
I
What
don't
if they
know.
have their own? That'd be interesting too. I feel like you can't really hear about that side of how they actually do that.
Yeah, it's kind of, and well, one of the things about that side is no one liked doing it because it takes forever and it's always out of date. But for games for the shipping game you had to do it, it's just while you're developing it, it's usually wrong, or
Right.
you know, you're having to wait 12 hours for it to go into the queue to bake overnight. I remember hearing about that with the Half-Life Alyx developer commentary.
Oh,
I mean, they have some real-time shadows and other things, but a lot of their stuff is, like, the game is very baked. Like, you play the game and you're like, wow, that looks great, and then you realize it looks great because it's very static. Just they realize that VR does not do well with highly dynamic, highly complex
oh yeah.
rendering,
So-
so they're like, let's make this simpler, and they
I
did.
think I remember hearing similar with early Frostbite, but it was like a pain point where I think if you moved anything in the scene, you had to wait for it
Oh,
to
ooh.
regenerate. So people would be like talking about having to wait, like they would like queue up actions and then have to like wait like an hour to see the result.
What the heck? That's just... Ugh. Queue maps leave questions. No clue. More structures. Tetracoordinate. Tetrahedron transform. Checkerboard.
That's why those buildings look really like diamond-like.
Oh, it's like, oh, it's octahedral. No, it's a
Yeah, octant coding, right?
a what?
Octant coding?
Oh,
Yeah, you're right. It's an octahedron, and it's a way of just the cheap sphere mapping into 2D texture.
Yeah. And it's like, it has decent distortion ratio compared to like a cube map or just a straight IBL encoding where you're just warping it.
Yeah, Morgan McGuire did a really good paper in the ACGT that compared different normal compression algorithms. And I think this was the most favorable one, was called octant coded. I'll drop a link for that in the chat.
Sick. Light info. Environment info. Huh. Is odd frame. I like how that's a whole integer. They just store it. Yeah. Well, I guess it's a Boolean, so it's really not a whole integer, but regardless, breaking. So these are all the global illumination stuff. Oh, we got shadow passes, finally. We're only halfway through and we're finally at shadows. Okay, lots of shadows. Lots of shadow maps. Neat. E. Octahedral. Ah. Does it have...
Yeah, you keep on scrolling down. There's a nice little picture. Not yeah. There's keep going. There's one of an octahedron in there. Ah, there we go.
Hey.
That's the oct encoding mapping right there.
Oh,
So you can see how.
neat. Okay.
Yep. You kind of flatten that sphere into an octahedron and then unwrap it into a
That's
2D
neat.
texture.
It's gonna have some warping, but like it easily stores in a square, which is super convenient if you want to have a whole bunch of spheres like, around the scene.
Yeah, exactly. And the mapping is relatively easy too.
Yeah.
Yeah.
Because like you can imagine taking a sphere and just kind of like looking at it from above and then unwrapping the bottom outwards, and that's all you have to do. I mean, other than, you know, turning it into an octahedron first too. I wonder if there's other pictures.
Yeah, actually, if you scroll up too, it gives you, like, there's pretty good source code that makes it pretty easy to, yep, oct float. Yeah, so there's the unpacking right there, and the packing's right above it.
So, let's see if I can copy. I'll just paste this in my text editor for later. Nah. Oct16. Precise float 32 by 3 to oct-n encoding. I like their error analysis. Is this like an error analysis? Floor, ceiling. Do the comparison. Oh. Oh, there's a whole bunch of them. Distribution of unit vectors. Interesting. Okay. Shadows. Is there anything... I wonder if there's anything interesting they do here. Like billboard particles. Deferred lighting. We're finally at lighting. Deferred fragment shader that does what a deferred fragment shader does. Okay. Ugh. Ooh. That's my reaction to the zombie creature. So this is applying the SSSSS stuff and doing the computation for that.
I guess the tone mapping's already happened with this. It's like
Oh,
when you see the output up above, like look how
oh,
like fine, yeah.
this is specular. This is diffuse. I think there's like a light in this guy's face.
Oh, sorry, I meant I scrolled down actually.
Oh, oh,
Lost where you were. A little bit further, like the big output, you can see like his face is not bright, so they must have done the like tone mapping, right?
I don't know. Some of the times he's like shown the final swap chain output just for reference.
Oh, so this might be like later on.
But no, it can't be because it's the out deferred out. It's not the final swap chain.
That's also the out deferred is in a HDR format.
Ye
Oh, so maybe it's just this is just how he's showing it, but it actually has all the info still.
The author might have fiddled with the histogram slider in RenderDoc to compress the range or something.
Ye I mean, some of these like it's mostly black, and it'd be you can't even see it unless you fiddle with the sliders to make them visible.
Also, it looks like the base color metallic thing is pretty dark, so maybe that's why it ends up not being so bright.
Well, I mean, well, the brightness of your base color is something I've read people discussing, that it's kind of a black art because you don't want your base color affecting the total luminosity, but it is true that black is going to be darker than a white color, so but he is interesting. Got our screen space reflection. Small diffuse default. Okay, we got screen space cone traced reflections. These are the screen space reflections. That's a lot of reflections, I think. Because we got our hierarchical Z buffer for the SSR.
I have a question. How does the hierarchical Z buffer help with SSR?
I have to assume that the further you are in the scene, the lower the MIP level to be used, so they don't have to do as much samples, and like they won't get aliasing. That's my assumption. I actually am not really confident.
The high Z buffer is used as an acceleration structure for ray tracing, screen space ray tracing. So it lets you skip. Instead of taking fixed steps, it lets you skip potentially large amounts of space at a time.
No, I don't want to.
If you look at the images for the
Oh
Husky,
yeah, I think I get it. Yeah, that makes sense.
and they use a conservative filter when they downsample, so
Right.
that you get the maximum safe distance to travel within that block. So that's why it looks like the bright red is growing.
It's because it's like a
Because
max filter.
Yeah, it's a max or min depending
It's a-
on
yeah,
whether we have.
It's a mipmap max filter.
Yeah. And each mipmap stores the inside that pixel what is the minimum and or maximum value, depending on your MIP order, your MIP direction. Your depth direction, I should say. Go back to where we were, which is like here. So yeah, that's what. Yeah. So in a nutshell. So these are the. Wait. This diffuse. This generated SSR. This new diffuse. And then they do the HDR tone mapping and other stuff. So like we can see very clearly that there's a lot more light in the post SSR. So there's a lot of light being taken from SSR to illuminate the scene. Of course, then it immediately gets turned dark because, you know, we're looking at just the diffuse. We're not actually looking at the lighting value or the final lighting. But interesting. Oh boy, a whole bunch of structures that I just don't. Hey, light shafts. So we have light. Yeah. Light volumes, in a sense. Oh. Ooh. That's an IES light table.
Oh, so I know about that. Or if it's what I think it is, the IES, it's
Yeah.
standard for point lights, right? They describe the casting patterns of point lights. Yep.
What was this Unreal Engine's documentation for? But yeah, it's like you encode the shape of the point light. It's really kind of like a spotlight, if you will, but. And then, yeah, and then they're like using that to create a shadow, not a shadow volume, but like a, create a light shaft. Oh boy. Yeah, because you're kind of like volumetric light thingies. So. Neat. Lens flares. Yeah, we gotta get those lens flares going. You blow out your vision with them. What?
I wonder how they get the anamorphic lens flare, like the really long, thin flares?
Uh,
Oh,
You
they
could
use
just
this
use an
principle.
ellipse.
they do what?
You could just use an ellipse instead of a circle.
Yeah, yeah.
Makes sense.
Oh, the images are actually just links to high-res video because GIF. This is rendering the light. You got the two headlights. You got your in. Ooh, it's. Oh, it's like those are hella complicated lens flares. Like they're separate. Like the discs are separate. Oh, it's the discs. The horizontal bits are separated. That's.
There's a lot going on.
Yeah. Like, I thought all of the spiky thing would all be one texture, but no, it's, like, rendered at multiple times.
Oh.
That's... interesting. Is that this one, the same one we just saw? I think it was. This is a different one. And it's also a minute and a half long. So that's just multiple lights, like multiple circles. This oval here. I can't tell if there's anything changing. Oh, it had added like, yeah, okay. So rather than having one shader that mimics all the effects, it seems like they have a whole bunch of different effects layered on top of each other. Different textures, I mean. Okay. Anti-aliasing. I'm starting to run out of steam to go through in detail on all these things. We're only halfway through. Well, a little past halfway. But
Yeah, it's been a while.
There's a lot.
Could talk about something else now. Maybe finish this up
Yeah.
some other time.
Just scroll through it. I mean, we're now into the post-processing, and there's just... Ugh. It's a gross burger.
Yeah, it is.
Yeah. We could finish this up another time. Because it's pretty much all post-processing from here on out. And we got CAS, and we got probably FSR stuff, and GUI.
I like the packed text texture. It looks kind of cool.
Oh, this one?
No, higher, I think.
Oh, yeah. I have to wonder why some of them... What an interest, like... These, like, make sense to me because they're, like, you know, on a grid. These are not.
Yeah.
And they're also different sizes. Are they, like...
Are they, like, overlapping? It looks like some in the middle.
Yeah!
Like, kind of the top, or, like, middle top right, there's, like, a U that looks like it's on top of another U or something.
Oh, yeah, I see that.
I don't know what's going on there.
I don't know. Looks like weird glitch text. Okay. We got all our necessary legal logos. You can see I recognize very few of these.
Same.
I know
WYs.
WYs. And that's about it. But these are like different studios. I mean, you got sound.
Oh, I see the Pirate Bay.
It looks like it, doesn't it?
Where they got all their assets from.
Oh, tactical gear. I guess that's like a licensing, like a vest or something.
I know what Technicolor is. I've never seen this logo, and I like have to wonder, do they like pivot or something? Because it's, you know, Technicolor is a very old term. So, oh boy, oh okay. I'm getting this thing, which we were talking about.
Temporal glare.
Temporal stuff. So we might want to look at it in a bit. Okay. Yeah, I think we should just hang up this article and finish it next week.
Is that a burger?
I believe it is. I see like
It looks
bacon,
like-
cheese, moldy.
It looks like the nasty burger from SpongeBob.
Yeah. I imagine this is like a burger that's been like left out after the apocalypse. But I don't see enough mold for that. Okay, I'm gonna stop the recording.